Good morning, geometry students. I hope that you're all doing well and had a good chance of rest and relax. And I know that one of you did have something that you and your family are trying to overcome right now. So I am praying about that, and I just know that um, there's been an awful lot of people who are in your corner. So we'll just pray about that. Jesus, please help that person whose family had something happen right before the Easter break. And I just pray for them and ask, Lord, that you'll help them. And I pray for that person's family member also that they're very concerned about. And I ask, Lord, that you give us a good lesson today that everybody will understand, and help me to explain it well, and give us a great day. In Jesus' name, amen. All right, so that was just our brief little introduction prayer, and we're going to talk today about volumes of pyramids and cones, and move ourselves right along with this. Now, do take extremely good notes. Do make sure that you do your homework assignment thoroughly so that you can understand the quiz that we're going to head for on Friday. You should be prepared to use all of your notes and use your homework assignments to help you to do that quiz. Make sure that you're asking good questions so that on Thursday I can help you with anything that you're having trouble or struggling with. And then Friday you'll be able to take a quiz on these sections that we're going to hit and do these problems on. So just please make sure that you're paying attention and ready for that. Okay, so volumes of pyramids and cones. And if you remember what a pyramid looks like, I have a nice little thing that I found right here that is a graphic of a pyramid, which will be helpful. Our pyramid can have a square on the bottom, or it can have any other shape, and then it has triangles going up the side, if you'll remember. And there's a formula that we need to discuss regarding pyramids, and it's the volume of the pyramid. We already talked about surface area of a pyramid, and you already had your quiz on that. But volume, we have here that base area of the base times the height, which is really very much tied to the volume of a prism. Okay, if you recall from when we were doing volumes of prism, but we have that little 1/3 on there. Because really, if you can picture it in your mind, your pyramid really actually divides up a prism that would go with it into 3 parts. So that's where the 1/3 kind of comes from. Now this is a kind of a neat little demonstration thing, and what I will do is I will do a link for that. I wish I could get rid of this advert, but let's see if we can make it go away. There we go. It's gone. So on this, we can manipulate 1/2 of the area of the base times the height. So this particular one just allows me very quickly to show you various different things on that, or it did a little while ago. Hold on, there we go. It allows us to, if you grab onto it, you can make the pyramid smaller, and it changes then the value. Here's our height has changed. The height, even if the pyramid is oblique and comes out like this, the height is going from that base to that corner. Even if it goes sideways or weirdly like that, you can have this up here. So we've got our area of our base times our height. This particular program allows us to change the base. So you've got, in this case with our square on the bottom, you have the area of the square is our area of our base times the height. So 1/3 the area of the base times the height for the volume formula for the pyramid. Now, I'll post this link a little bit later in your geometry page that you've been looking at. I'll post it in interactive geometry links so that if you want to play around with that a little bit, that you have the option to do that, because it's kind of neat to see it happening and seeing all those calculations, and you can do them yourself as well. So formula 1/3 base area of the base times the height. Now that one, of course, was the when the base of the pyramid was a square, but you can have all different kinds of shapes for the base of a pyramid, as you know, so we'll look at them a little bit later. One of the things that we can take a look at is like real life examples. The Great Pyramid of Giza has a height of 481 feet, and the length of each side of its square base, which is just like the example I showed, is 756 feet. So what we can do is we can figure out the volume of this giant pyramid using the formula and what I was just showing you with that interactive link, but you don't need the link for that, you just need the formula. So 1/3 of the base times the height. Now the base is a square base with 756 feet on each side. So that would be if we took this graphic that we had here and we extended it not to just be the 6.8 or even further on with that. You could change that to, if you could change that to being our number 756, we would be doing for our base 756 times 756, which you can use any calculator to find this number. And then so 1/3 of that number times the height, 481. Now how you go about calculating that, it's 1/3, so that means you're just taking this and dividing it by 3 and multiplying your answer times 481. And when you do that, you get over 91 million cubic feet. Do remember that when we're using volume, we're using cubic units. So to the nearest cubic foot means that even though there would be decimals afterwards, you're rounding it to the ones place. Okay, so that's a huge example of a really giant pyramid, but we can do small things also, like a snow cone cup. Now, this is a circular cone. So cones and pyramids are really just cousins to each other. It's 1/3 base times height again. Okay, but since the base is a circle, pi r squared is the area of the circle. So we're doing 1/3 area of a circle times the height of the cone, which is from the bottom all the way to the point of the cone. So the diameter we're given, and we're given the volume, and we need to find out how tall the snow cone cup is. Now, first thing we need to keep in mind is that we were given the diameter, and when you're trying to find the area of the base, you need to be thinking about the radius. So we need to be careful with that. We have volume equals 1/3 pi r squared times our height. Oh, we know the height. We're supposed to be finding the radius. Let me go back to here. Yeah. We know the height. We're trying to find the radius. So we have 12. And so we can manipulate that just a little bit so that you're taking 1/3 times 12. Remember, multiplication is commutative, so I can put the 1/3 next to the 12. So I get 4 pi r squared equals 300. I'm trying to get the r squared by itself, so I can divide both sides by 4 pi. Be very careful. Okay? You need to make sure that you're dividing 300 divided by 4 pi. If you're using this calculator, it's very easy to make a mistake. You need to divide it by 4 pi, so you have to use parentheses, because otherwise it's going to use the order of operations, and it's not going to group the 4 pi together. So our part answer here is 23.9 or 23.87. If you forgot to use the parentheses here, let me show you what happens. Okay, it's not going to group the 4 pi together. Order of operations says multiplication and division in order from left to right. So since we need to divide it by 4 pi and not just divide by 4 and then multiply by pi, you have to use these parentheses if you're doing this all in one shot in your calculator. The other option would be for you to take 4 times pi separately and then take 300 divided by that number. But 23.87 is our answer for that, and then we need to square root our 23.87. So square root 23.87. And so we get about 4.9 for our radius. But our question's asking us to find the diameter. So we have our radius now, so the diameter is 2 times that amount. 2 times 4.9 being 9.8. Okay, so we can use that. We can use the pyramid formula a little bit more basically. We did the one with the pyramid, the Great Pyramid of Giza, but like I said, the base does not have to be a square. This one does have a regular base. This is important. So we know what formula to use. The height is out here. It's oblique. It's smushed over like that. But it's still 1/3 base times the height, the area of the base times the height. So we need to calculate the area of the base. And the area of the base, remember our formula when you have a regular polygon is one half of the apothem times the perimeter. The apothem is given here as 3 meters. Okay, that 3 meters is going right in the center of the base. That's what an apothem is. The perimeter is 6, but there's 6 sides, so 36. So we're taking 1/2 of 3 times 36, which gives us 54. Okay. You can take 1/2 of 3 first, or you can take 1/2 of 36. Remember, multiplication is commutative, so it doesn't matter what order you do that in, you'll still get 54. So 1/3 of that base that we just found times the height of 9, and we get 162 meters, cubic meters in that. All right, so we have that. Now, another thing that snuck its way into this lesson is that idea again of where you can take different pieces and add them together to get volume. So here's a good practical problem. This does not involve pyramids, but it does involve volumes. If you wanted to make a wheelchair ramp, for example, and you needed to calculate the cost of the concrete for this, you would have a slab here, you'd have an angled piece here, and if you knew the dimensions, you had figured out the dimensions as far as what you need. And there are different ways, different things. There's a rise over run formula that's for standard for safety for wheelchair ramps, so they're not too steep. And then you've got this little landing where the wheelchair would have to stop. Concrete's costing $4 per foot, and if you wanted to figure out the cost, you'd need to figure out the volume of the 2 pieces and then add them together, because you can always divide it up into chunks. So we have basically 2 prisms here. We have 1 prism here, we have another prism here. This prism, somebody before had asked, does it matter what the base is and what the height is? On a rectangular prism, it really doesn't. When you have different shapes of prisms, remember that the lateral surfaces are the rectangles, and then the polygons that are the same are the bases on that. So on this, the base is most definitely the triangles, but on this one, the base could be this bottom and the height could be this way, And you could do that in either way. So just to hopefully clear that up. So here, and honestly, in a rectangular solid, many of you will just find it easier to do length times width times height, which is what this comes down to for this piece over here. If we think about the formula that your book gives with the base times the height, the area of the base, if we did 8 times 10, this would give us the bottom and the height being 2, and you get 160. And for those of you that say, wait a minute, what if I wanted this part to be the base and this part to be the height? Well, then you'd take 2 times 10 times 8, and you'd get the same answer. You'd get 160 cubic feet, which is also what other books show with the volume formula, length times width times height. So this part, pretty easy to get in any way. You're just multiplying the 3 numbers together. This one, it's a prism. Okay, you've got the triangles on the top and bottom, so those are the bases. And the height in this case would be 8 because it's this way. So we have, if we have 20 this way and 2 this way, to get the area of our triangle, which is big B, you'd have to do 1/2 of 20 times 2, and our height then being 8 this way. So 10 times 2, 20 times 8, 160 cubic feet here. These would not have to definitely match because it all depends on how long this piece is right here. It just happens to this time. So it's not like these are not doing the same math, 2 different problems here. So to get the total volume, you would have to add these 2 numbers. But that just gives us our volume. Our question's asking how much it costs, so you'd have to multiply that times the $4 per cubic foot and get 1,280 feet for that. Now there is another little topic that is mentioned in your book that is talking about the volume of platonic solids. I'm just choosing to do a glaze over on that. When you look at it, E represents the length of the edges, and I'm going to have you skip those questions. I did not choose to include it on your test, but for those of you that want to stretch yourself a little bit and do those 2 questions, go for it. But I didn't include them on the quiz or the test, so we don't really have to deal with that very much. All right, so your job is going to be to work on assignment 55 right now and do your very best on it. Make sure you're asking questions and getting those submitted in. And then you'll turn that in tomorrow before you start on watching lesson 9-6. All right, have a really good, blessed day, and take care of each other.